All right, y'all, the practice test. This is probably going to be a long video, but we're going to make this happen. Okay, so first of all, for the first three problems, a lot of you struggle with domain and range, but you shouldn't struggle with whether it's a function or whether it's linear or not, right? Is it a function? That means, does it pass the vertical line test, right? When it's a graph, does it pass the vertical line test? And in this case, when I draw a line, it goes through more than one point, so the answer is no. Whereas here, when I draw a line, I never go through this graph more than once, so it's a yes. And here, same thing. I never go through that graph more than once, so it's a yes. When I go through more than one, that's what makes it a no. And then for linear or nonlinear, do these points make a straight line? No. That's why it's not a linear. Is that a straight line? Yes, linear. Sorry, I should have put nonlinear here. Although if you put no, I'd probably be okay with that. And then same thing here, straight line, so it's linear. Okay? Now in terms of domain and range, for this here, it's really a matter of if you label these points, right? If you label this point, this is -1, 1, this is -2, 3, this is -2, -2, and this is -1, -3. The domain is just the x values and the range is the y value. So when it's in point form like this, you just write down all the x's. So I got -2. I got -2 again. If you write it again, that's okay. And I got, domain, the x's, -2 and -1. If you wrote -2, -2, -1, -1, that's right, because that is all the x's, those first values, right? Now the y's are the second values. So all the y's make up my range, okay? So my y's, and it doesn't matter the order, I'm just going to go right from 3, 1, -2, and -3. And that's it. That's the domain and range on this. For this one, please don't make this harder than what it is. It keeps going up, it keeps going down. It keeps going right, it keeps going left. The domain and range for every single line is all real numbers. If you remember, that's all real numbers. Okay? So just write all real numbers or just give me that funky symbol. Okay? Any line has that always. Okay? Now this is not a line, this is a line segment. It is endpoint here at 4, -1, and here, excuse me, at -1, 3. This is the x values. So the x is between -1 and 4. So put the x between -1 and 4. The y would go between the y values, -1 and 3, right? This y and that y. And -1 to 3 works like that. That's it. That's the domain and range for that too, okay? All right, moving along. Graph something that is a linear function, which literally means draw a line. Boop. Good enough, okay? Draw a nonlinear function. So draw something that's not a line. I'm just going to draw a parabola. But if you did one of these, if you did a circle, anything that's not a line would be acceptable there. So graph something that's not a function. I better not draw a line. But this also means no pass VLT, right? So what doesn't pass the vertical line test? Well, something that kind of comes off like that. Because, right, if I put a vertical line, it would go through more than once. If I put another vertical line, anything I draw through here would end up going through it more than once, and that's why it's not a function, right? You could do something like this would not be a function, right? Even something like this would not be a function, right? But it is what it is. Let's move on. 7, 8, and 9 are just plug in x. So you're going to find g of -1, you're going to find g of 0, and g of 2. And all that means is just go plug it in right there. So really, I'm going to have this over and over. And you know what? It works the same thing on the next problem. I'm going to find g of -1. Excuse me, f of -1, because it's f, right? F of 0 and f of 2. And all that means, again, is go plug it in right there with those numbers, right? So I'm plugging in -1, I'm plugging in 0, and I'm plugging in 2. I'm plugging in -1, I'm plugging in 0, I'm plugging in 3. Sorry, it says 3. Sorry, 3. I'm going too fast here. And then just go plug that into a calculator, right? When I plug this into a calculator, I get 5. When I plug this into a calculator, I get 2. And when I plug this into a calculator, I get -7. And that gives me the x, which of course we know that's x, it tells us right there, and the y for every point. So the first one is -1, 5. The second one is 0, 2. And the third one is 2, negative 7. Those are my answers, okay? So similarly here, really I could start out this problem by putting my x values in there right away, right? And then once I go solving these, right, I get negative 7, negative 4, and 5. Those are the numbers that go here. Okay, so plugging in for x versus the ones at the bottom is plugging in for y. Again, this is what h of x equals, right? So we're just going to substitute that 17 right there. And then I think most of you know how to solve this problem. Maybe it helps if I just draw that line there. Oh yeah, I got a minus 5. I get 12 equals negative 2x, and then divide. X equals negative 6. Same exact thing on this problem. F of x is f of x. So I'm going to substitute that in for f of x and just write everything else down, right? Do the same thing I did on the previous problem. Get rid of this. Maybe you draw that bar. Get rid of this to get negative 18 equals 3x, and divide to get x equals negative 6. Okay? That's it. That's how you do those problems. I didn't even ask you to write it as an ordered pair, so you don't need to leave your answers like we did on those problems there. You just needed to find x. And it is not always negative 6. It just happened to work out on those two problems. Okay? All right, next page. Right. On the next page, we're doing the same thing for these graphs that we just got done with. I'm going to do this one first because I think it's a little easier. We're just going to plug negative 1, 0, and 1 in. So again, I'm going 3 times negative 1 plus 1. I'm going 3 times 0 plus 1, and 3 times 1 plus 1. And that's how I get these answers. This is negative 2, this is 1, and this is 4. That's how I get those numbers. Right? I'm going to come back to graphing that. Let's go over here. So same thing, but a lot of you forget that when there's a negative here, you got to stick that in front. So maybe you make that a negative 1, right? Because then you know it's negative 1 times negative 2, minus 2. Negative 1 times 0 minus 2. And negative 1 times 2 minus 2, like that. For the first one, you're going to get 0. For this one, you're going to get negative 2. And for this one, again, when I plug in 2, I'm going to get negative 4. Okay. Now, how do I graph these? This is the point, negative 2, 0, 0, negative 2, and 2, negative 4. So remember, negative 2 in the x. Look at where the x is. Go negative 2. Well, there it is right there. And then 0 up or down. So I'm just going to put my point right there. The next one, and so these points are a little hard because of the 0. But the next one, 0, negative 2, means go 0 in the x and then negative 2 in the y. And that puts you right here. And then 2, negative 4 is 2 in the x, positive, and negative 4 in the y. Put you there. Boom. Done. Okay, similarly on number 12, so this is negative 1, negative 2, which means negative 1, negative 2 right here. 0, 1 means 0 in the x and 1 in the y. And 1, 4 means 1 in the positive x and 4 in the positive y. And they should form lines. And if they don't, you did something wrong with probably your points up here. So go check which one doesn't fit. Okay? All right. Moving along here. 13 and 14, right? Find the x and y intercepts. If you remember, to find the x-intercept, we just set the x term equal to the number. We literally just cover that up and solve that problem. So I get 3x equals 6, and I just divide, right? I get x equals 2. Now remember, for the x and y points, the x goes where the x is. What goes in the other spot? Well, in order for this to just go away, it's because I times by 0, right? So it's 2, 0. For the y-intercept, I set the y term equal to the number. So 2y equals 6, divide. I get y equals 3. Again, if this is x and y, you better put the y in the right place. And again, the reason this goes away is because I'm plugging 0 in there to make it disappear. So it's 0, comma 3. Okay? So similarly on number 14, right, 2x equals 4, and negative 1y equals 4. Remember, that means negative 1. Right? When I divide here, I get x to be 2, so 2, 0. When I divide here, so divided by a negative 1. Those cancel. Y equals negative 4, and 0 goes in the x. Okay? Same thing every time. All right? And then it wants you to graph those points. Right? This was 2 parts of section 3.4. So where does x equal 2? Well, right here. Where does y equal 3? Well, right here. Right? And really, look, again, the points tell us 2, 0 is over 2, up 0. 0, 3 is over 0, out 3. And I just connect my dots. There's my line. Okay? Same thing here. X equals 2 right here, 2, 0. 0, negative 4 is way down here. And boom, there's my graph for that one. Okay? All right, so let me show you again. 0, negative 4 was down here. 2, 0 was here. Okay? 0, 3 is here. 2, 0 is here. And again, it's just connecting dots. This is not the point 2, 3. That is not the point. This is not the point 2, negative 4. Because if you just graph that point 2, 3, that's not even on your line, right? So don't do that. Don't do that. It's the X and the Y intercepts, which means it's on the actual X and Y axis, okay? Down below, identify the slope, right? We did this multiple ways, right? We know we can tell if it's linear or not based on, remember we did like minus 2, minus 2, minus 2, minus 2, and this is plus 1, plus 1, plus 1, plus 1. So I know it's linear because it's consistent, but all we had to do is take the y over the x. And remember, this just means y, right? So all I got to do is literally just go the change in the y, which is negative 2, over the change in the x, which is 1. The answer is just negative 2. Now another way to think about this is if you just call it, we use this formula, this y2 minus y1 over x2 minus x1, right? So if I take and just make this, let's see, x1, y1, x2, y2, I would just go plugging it in here. I'd go y2, which is 2, minus y1, which is 4, divided by x2, which is negative 1, minus, like that, x1, and I get negative 2 on top, and I get a zip zap there, and I get a positive 1 on bottom, and guess what? I still get the answer. But I don't even need to use the formula when I'm given a table. Just figure out what the difference is, right? Like right here, this is going plus 1, plus 1, plus 1, plus 1. On top, excuse me, it's going plus 3 all the way across. So when I go y over x, again, what that really means is t of x over x, and the change in y is 1, and the change in x is 3. So it's just 1/3. If I use that formula, I can even just go this way, 1 minus 2 over 0 minus 3. I get negative 1 over negative 3, which is a positive 1/3. Okay? All right, that's that page. Let's move on. Okay? All right, so the slope is always the number in front of x when it's in y equals mx plus b form, right? We know that m is the slope, and we know that b is the y-intercept. And if it's not in this form, we can get it into that form by just solving it for y. But this is already solved for y. So there's my slope, 4. There's my y-intercept, 0, negative 1. Or if you just put negative 1 there, that's fine. And why is that significant? Because we graph that point first, 0, negative 1. Where does y equal 1? Negative 1 right there. And then the slope, remember, that means 4 over 1, right? So I'd go up 1, 2, right? This is not 1. This is 0. Up 1 box, 2 box, 3 box, 4 box, over 1. There's my dot. That's all I need. There's my graph. Okay. On this one, there is no x. So really that means 0x. So the slope is 0. The y-intercept is always that number by itself. So that's 0, negative 1. Or again, just negative 1 because it's right here. Okay. If it has a slope of 0, that should tell you something. That is either one of these lines or one of these lines. But y equals negative 1 is not right here. If you did a line like this, this is y equals 0, this is y equals 2. Where else does y equal negative 1? Well, that is a horizontal line because this is 3, negative 1. This is negative 2, negative 1. So y equals negative 1. It's just that line right there. Okay. For the next one, it's in a different order, but the number next to x is my slope. So negative 1/3 is my slope. And the number by itself is always my y-intercept, 0, 1. So I'm going to start at 0, 1. And I'm going to go, remember, it's always go right. So this was up and right. This one is down and right. So I go down 1, right 3, put my dot, connect my dots. Done. Easy enough. Okay? On number 20, though, it's a little more work. It is not in y equals mx plus b form. So to solve it for y, we would just minus 2x to both sides. I get 2y equals negative 2x plus 6, or 6 minus 2x. I don't care how you write that. And I just divide everything by 2. It is always the same steps. I'm never going to make them that hard for you. And now that I have it in this form, the slope is negative 1, and the y-intercept is 3. So go to 0, 3, plot that point. Your slope, negative 1, remember, anytime it's a whole number, we can just put it over 1. So down 1, right 1, down 1, right 1. Connect your dots. I don't even need 3 points. I only need 2. Okay? That's it. That's all of those graphs. Okay, let's move on to 21 through 23 here. And these should be really easy because the x-intercept is where it crosses the x-axis. What is the coordinates of that point? It is 4, 0. The y-intercept is the coordinates of that right there, which is 0, negative 2. So right away, we can write those in, 4, 0, 0, negative 2. Now what's the slope? If you remember, the slope is just the rise over the run, right? So as I do the rise over the run, from this point to that point, I go up 2 boxes, positive, right, because I'm going up, and then right 1, 2, 3, 4 boxes, 4 boxes. That reduces to 1 over 2. That's the slope, okay? If you left it as 2 over 4, I'd probably only take a half a point off. All right, here's my y-intercept at 0, 2. Let's write that down. Here's my x-intercept at 1, 0. Easy enough. The slope now, again, I can use the y2 minus 1 formula, or just remember, again, it's rise over run. So to get from here to here, I went down 2. Down 2 means negative, and right 1. And that is negative 2. Negative 2 divided by 1, right? If you even wrote 0.5 here, I'd be okay with that too. Okay? But it's not the same here. On this one, x-intercept, well, that's pretty clear. That's at negative 3, 0. The y-intercept, though, this never crosses the y-axis. So none, right? Don't put 0, because 0 would mean it crosses right here. Okay? None. The slope here, though, well, we said anything that, when you have a line like this, if you put a 0 through it, that's the undefined symbol. Whereas if I have a line like this, that's just 0. So if you can put a line through and it gives you the undefined symbol, then the slope is undefined. Okay? And I don't care if you write the symbol or just the word undefined. Okay? All right, this is probably going to be about 20 minutes by the time we get done with this, maybe a little bit longer. Let's keep going here. All right, so for the last problem, okay, that's not PSAT practice stuff that we'll kind of get to here. Which one is dependent, which one's not? So as I read this problem, the function g equals negative 3h plus 27 represents the number of gallons that remain in a gas tank after h hours. So is the hours dependent on the gallons, or is the gallons dependent on the hours? Listen, you travel 5 hours in a car, you're going to go through so much gas. You're not going to travel gas in your car to go through hours, right? So the gas is dependent on the hours. So the gallons, or gas, is going to be your dependent variable, which means that hours is going to be your independent variable, and time is always independent, because time happens no matter what, right? Minutes, hours, days, years, whatever. They are always independent, okay? Now, how large is the gas tank? Well, the gas tank, the largest amount is the y-intercept. It's where you start. So it's just 27 gallons. It's where you start, right? How many gallons will it take after 4 hours? Now remember, hours is h, so that just means you're plugging it in right there. So you would go g equals negative 3 times 4 plus 27, right? Which is negative 12 plus 27, which is 15 gallons. Okay. How many hours will the tank be empty? Well, empty means I have 0 gallons. So I know you know how to solve this problem. You put a little line there. You start minusing the 27 first. And then you divide. So you get 9 hours, because that's what this divided by this is, right? And then how many gallons per hour does the car use? This just means the slope. 3 gallons per hour, right? That's it. That's all that is, okay? All right, when I look at the next problem, it says y equals 5x plus p, where p is a constant, which just means it's a number. It's graphed in that plane and passes through this point. What's the value of p? Well, this is x and y, right? So if I go plug it into x and y, I'll have nothing left but p to solve for. So I put y in here, 1 equals 5 times negative 2 plus p, which 1 equals negative 10 plus p, and to solve for this, you just do the opposite of that. 1 plus 10 is 11. That's it, okay? On the next problem, it's a lot of words. Some of you get a little frustrated with words. Okay, it says an advertisement states that the printing rate of a certain printer is 400 characters per second. According to convention, that one word consists of 5 characters. What would be the advertised print rate in words per minute? words per minute. It's like miles per hour. You would divide it, right? So the words, right? This gets a little bit confusing here, right? It says that we have, boy, there is a lot to this one. This is probably going to be an extra credit problem, okay? So words per minute is what we need. So to get there, I know I have 400 characters per 1 second. Sorry, I didn't mean to do that. 400 characters per 1 second. And I'm going to times that with 1 word per 5 characters. And then I'm going to times that because I'm trying to find out how many per minute, but this is broken down into seconds. So I need to times it by 60 seconds per 1 minute. And now look what happens, right? The seconds and the seconds cancel each other out. The characters and the characters cancel each other out. Now I have words per minute. And I just got to times the tops and times the bottoms. So on bottom, 1 times 5 times 1 is just 5. On top, 400 times 1 is 400. Times 60, well, you probably need a calculator for that, but it's 4,800. But that's not the answer. I have to divide it. And I just did something wrong. That's not 4,800, sorry. It's 24000 divided by 5, right? And when I divide that out, well, guess what I get? That's why I put the answer in there accidentally. It's 4,800, right? There it is, B. I'm telling you guys, I'm not going to give you something that hard. That's good. If that's on the test, that's going to be extra credit, okay? There we are, just under 22 minutes. There's the practice test. Make sure you're studying this to get yourself ready for the test.